Alright everyone, welcome back. Use a new color here, why not? Use blue. So we're going to do a couple more examples using factor theorem, and then we're going to get to your homework and also to the crypto quip because it is Tuesday. So let's take a look at this graph. They're asking us to find an equation for a third degree polynomial function graphed below. So we have this polynomial, and what we learned in the last example is if we know what these intercepts are, those are our zeros, we can get the factors, and then we'll be able to find the equation for this polynomial. So the zeros here, it looks like that first one is at -5, the next one's at -3, and this last one is at +2. So there's our zeros, so then our factors are going to be x plus 5, because remember we want those to cancel out. -5 plus 5 gives us 0. And then times x plus 3, and the last one over here is going to be x minus 2. I almost feel like the positive ones are easier, because if 2 is our 0, we know x minus 2 is going to be the factor. So now we have our factors, but the question is that really the polynomial? Is p of x just equal to those values? Well, think about it this way. Is there any other polynomial that has those three zeros? Well, of course there is. There's a whole bunch of them. Here are just a few examples. So the blue one is still our polynomial that, oh no, none of these are the polynomial we're looking at actually, but these are all polynomials that have zeros at -5, -3, and 2. So how can we be sure that this is right? Well, there's kind of a simple way to do it. We look at the y-intercept right here. The y-intercept tells a whole lot of things. Notice all the y-intercepts here are different. So this y-intercept that we're concerned with is at 0, -60. So we know that p of 0 should equal -60. Well, let's check right now. If we plug in 0 for all the x's, let's see if we get -60. So we plug in 0 for all the x's. Let's write it over here. 0 for x here would just give us 5. 0 for x here would just give us 3. 0 for x here would give us a -2. 5 times 3 is 15 times -2 is -30. Uh-oh. Well, that is not -60. So this can't be our polynomial. That's wrong. So how do we know what we can do to get that -60? Well, some of you might have already figured out we can just multiply -30 by 2. If we just multiply it by 2, we'll get to that -60. So all you have to do is just plunk a 2 in front. So it's going to be 2 times x plus 5 times x plus 3 times x minus 2. And some of you might be saying, well, how do we know we can just do that? How do we know there aren't more factors out here? How do we know we don't have to take one of these to a power or something? Well, there are a couple ways. One is that factor theorem tells us that x minus c is a factor if and only if c is a 0. If and only if c is a 0. So if we have only these three zeros, then these can be the only factors. These can be the only factors. Also, we're told it's a third degree polynomial, so I can't have any more x's out here. There's no way to have any more x's out here. So then the only thing that can change is multiplying by what's called a constant. That's the only other thing we can do. So that means our p of x is going to be some sort of 2x cubed plus a whole bunch of other stuff. If we wanted to expand this out, we could, but it just says to find an equation. And hey, we found an equation. It's in factored form, but that's all we have to do. So to recap that, if we're given a graph, we just look at the zeros. That gives us the three factors. And then we have to check the y-intercept to see when we plug in 0, do we get out the value we want? We didn't, so we know that we have to put a constant factor in front, a constant 2 that gets us to our -60 there. Let's try one more example. So this time they give us the zeros. Well, that's nice of them. We don't have to look at a graph. We certainly don't have to graph it ourselves. They just give us the zeros. And they tell us it's a third degree again, so we're going to have three factors, each with x. An x, and x, and another x. And they want integer coefficients, and we'll talk about that in a second. So let's talk about just given the factors, given the zeros, they give us these three zeros, and factor theorem tells us that the factors are just going to subtract the zeros. So x minus 1 will be a factor, x minus 3/5 will be a factor, and x plus it would be 2/3. So that is a third degree polynomial that has those three zeros. But we need these integer coefficients. If you were to multiply this out, either using boxes or using repeated distribution, you can see we would have like 3/5 x, and we would have 2/3 x squared. Like there's going to be some ugly, ugly numbers. Even just the constant term is going to be 1 times 3/5 times 2/3, which I think would be 6/15. That is definitely not an integer. So the question is, how can we change these factors? How can we change these factors so they're going to give us integers? So we want these to be the zeros. And you might remember this from our warm-up problem in the first video. We want these to be factors, but we need these to not have any fractions in them. So how can 3/5 be a factor, or sorry, a zero? How can 3/5 be a zero without just having x minus 3/5? Well, I think it's easiest just to kind of look at this and think about it for a second. We'll go through a more concrete way to do it in a second, but x minus 1 is good because it's all integers in here. Now, if I want 3/5 to be a 0, check this out. If I do 5x, then that x, when I plug in 3/5, the 5's are going to cancel, and I'll be left with 3, so I have to subtract off a 3. And then the last one, I want 2/3 to be the 0. So let's see, I want 3x, because when I plug in negative 2/3, when I plug in negative 2/3, the 3's will cancel. I'll be left with a negative 2, so I just have to add 2. And right there, we're done. Now, some of you might be saying, what the heck did you just do? How did you get this 5x minus 3? Well, because I know that if 3/5 is a 0, the 5's will cancel, and then the 3's will cancel, I'll get a 0. But the way to do it a little bit more concrete is based on what we talked about last time. So it can't be this because they don't have integer coefficients. But what we talked about in the last slide was we could put a constant in front here, and these will still be the factors. They will still give us the zeros when we plug in these three values. So what we can do is put some constants in here that clear those fractions. So what we can do is say, okay, I'm going to make p of x, so x minus 1 is good. What I'm going to do is I'm going to sneak in a 5 here and multiply it by x minus 3/5. And then I'm going to sneak in a 3 as well, times x plus 2/3. So all I did there was really just multiply by 15. I put a 15 in front. I put a 15 in front because there's a 5 and a 3. And the reason I chose 5 is because I want to cancel with that 5. And the reason I chose 3 is because I want to cancel it with that 3. I could have chosen 10 or 15 or 20, anything that will cancel out the 5. But 5 is the simplest one. 3 here could have been, well, 3, 6, 9, any multiple of 3 that will cancel out that 3, but 3, once again, is the simplest one to use. So now I can distribute these in. So x minus 1 I leave alone. Here I have, oh, look at that, 5x. The 5's will cancel over there, so it'll be minus 3. And then it'll be 3x, distributing here as well. On the right side, the 3's cancel. It'll be plus 2. And there I have my polynomial. That'll serve you very well in the homework, which is right here. So the homework that I'd like you to try, first of all, I want you to try Lesson Master 7.4, which is in your pink packet. Remember, the solutions to that are on Moodle. And I'd also like you to try this challenge problem that I've got up here. You can do this challenge problem using the stuff we've learned from Chapter 7. You'll be using some of the stuff that you learned in 7.3. That's your little hint there. And let's take a look here. So I give you that negative 3 is a 0. So I give you that negative 3 is a 0, and I want you to factor this completely. So we have a cubic, so you should end up with 3 factors. I tell you one of the zeros, so you can use factor theorem to know what one of those factors is. But because I know one factor doesn't mean I know the other 2. So what I want you to do is think about how could I figure out what those other 2 factors are. And the last hint I'll give you is that it's going to use some kind of division. It's going to use some kind of division. Because you know one factor, or one zero, you know the factor, so think about how you can use division to be able to divide out that factor. Alright, best of luck. I also have a Crypto Quip Tuesday for you here. So feel free to go back and watch any of the video. It's yours to take at your pace. And when you're done, you can take a look at 7.4, at the Lesson Master in the pink packet, and also give that challenge problem a shot. So you can go back and pause it on that problem if you need to look at it again. Give this a shot. The hint I'll give you on this is I wrote it on an airplane. So enjoy, and I'll see you tomorrow in our next video.